Hi everybody. I'm gonna just make this video to show you solutions to Quiz 6. And because it's a running theme, I'm gonna put the name Don't Forget the Baby on here, okay? So why am I saying don't forget the baby? That's just my silly way of referring to the chain rule, which is that if we have a function inside a function, when we take the derivative, we take the derivative of the outside, and then we have to multiply by the derivative of the inside. So when I write this, right, I have to say f prime of g of x times g prime of x. Okay, that's the chain rule. So when I say don't forget the baby, it means we have to multiply by this derivative of the function that's maybe sometimes hidden inside another function. Here, I have a situation where I've got a y on both sides of some equation. This tells me I'm going to use implicit differentiation. Okay, which means I'm going to take the derivative of both sides with respect to x. Okay, why am I taking it with respect to x? Because what's the slope of the tangent line, okay, to the implicitly defined curve at a point x comma y? It's dy dx. The ratio of changes in y to changes in x. This is rise over run. At a single point, that's the derivative. Okay, so this is also the same thing as y prime. Y prime means the same thing. It's the slope of a tangent line at some specific point. Now, when I when I see something like this, I notice that I'm going to need the product rule here, and I have to remember that that y has a hidden function inside. Okay, so what I'm going to do is I'm going to do this derivative, and I'm going to use the product rule. Right, so I'm going to write that right next to it as PR, product rule, and this is I want to change colors a little bit. Well, no, here I'll start with. So you have to take the derivative of the first one, and that's just dy dx. Right? And then you have to multiply by the second one, but the second one's not changing, so I'm going to do it again in black. So. Okay, and what I'm going to do is I'm going to now add plus the derivative of cosine is minus sine of x, but then I have to multiply by y. Okay. If we keep going, let's keep going, and I'm just going to go to blue now because everything's going to change. So this, the derivative of this term, is going to be 2 times 4 times x to the 1. So we're just using the power rule. So this becomes 8x to the first power, and then I'm adding the same kind of thing, except this time this one has a baby. So it's going to be 6y times dy dx. So now what we have to do is we want to isolate this. Okay, so now we have to solve for dy dx. Okay, and that's going to look like getting everything with the dy dx on one side and everything else on the other side. So because of this minus right here, I'm going to get everything with the dy dx on this side. So I'm going to add this. Right, so I'm going to plus sine of x times y, and then I'm going to subtract this. So without doing a lot more detail, it becomes dy dx times cosine x, and then I'm going to subtract. I'm going to minus 6y times dy dx, and that's going to equal 8x plus sine y dy dx. Now I'm going to factor this out. I get cosine x minus 6y, and then plus equals 8x plus sine of x times y, and therefore we get the final answer, dy dx is equal to, after we divide both sides by this, right? We're going to divide both sides by that, and we get dy dx is equal to 8x plus sine of x times y divided by, that's a times y, divided by cosine x minus 6y. Okay. Now, this one explicitly tells me to use logarithmic differentiation. Okay. And the steps of logarithmic differentiation are: 1, we take ln on both sides. Okay. We're going to 2, simplify, right, using ln properties. Okay, then 3, we use implicit differentiation. Okay, so I'm gonna take natural log of this, okay, and natural log of this. So the next line here is I'm going to break up all these things. See how I have a power, I have multiplication, I have also this thing is related to the 1/9 power, okay, and then I have multiplication right here. We have division. This is really 1/2 power. So we can actually think of this as to the negative 1/2 power. So natural log of y, have not taken the derivative yet, equals, okay, it's going to be 5 times the natural log of 2x plus 3, okay, plus 1/9 times the natural log of 7x minus 5, okay, plus the natural log of cosine x. Okay. And then we do the bottom part. Since that's division, it becomes a minus, and the 1/2 comes down, and we have the natural log of tangent x. Okay, so that's step 1 and 2. I did them together. And then, so if you want to pause it for a second and make sure you agree with that, that's a good idea. Now I'm going to take the derivative of both sides. Okay, and so that I'm going to denote by this. So I'm taking the derivative of everything on both sides, okay? d dx, okay? And so if you remember, right, d dx of natural log of y, okay, is going to equal the natural log of y is going to be 1 over y, but there's going to be a derivative multiplying that, so it's y prime over y. And so only after the derivative do we get this y prime over y. I never want to see you with a natural log of y over here and then some derivative stuff over here. We are now taking the derivative. Okay, we are taking the derivative in this step. Okay, that's what we're doing right here. Now let's do it. Notice all of these natural log terms, they're going to be something over what's inside, okay, and then what's the derivative of this thing is 2, okay, so I have I have 5 times that, okay, plus, and I'm going to have 1/9 times something over 7x minus 5, and what's the derivative of the inside? 7, okay, because these are just linear things inside, okay, and then I'm going to have plus, and it's going to be over cosine x, but then what's the derivative of cosine x? That's right, minus sine x. Okay, then I have minus 1/2. So it's ln of tangent x, so there's going to be a tangent x down here, and what's the derivative of tangent x? Secant squared x. Okay. Okay. The last step here is to multiply both sides by y, and so really we have y prime is equal to y times. Okay, we'll clean all this up. This is 10 over 2x plus 3 plus, I'm just going to do it like this, 7 over 9 times 7x minus 5. Okay, and then I'm going to bring this minus sign in the front, get minus sine x cosine x. Okay, then minus, I'm just going to leave this as secant squared x divided by 2 tangent x. Okay, and so the last step is to fully write out, what is this? Y prime is going to equal, okay, remember what y was? It's this whole thing right here. Okay, I'm going to write it in blue to make the point. Okay, it's this thing in here is 2x plus 3 to the 5th times the 9th root of, I'm going to need more room, towards the 9th root of 7x minus 5, okay, times cosine x, all divided by square root of tangent x. See how then the natural log makes that a lot easier than if you didn't do it this way. Okay, so I'm going to go back to red to write the rest of our derivative. Okay, so this is going to be 10 over, oh, you know what, I'm going to cheat. Since I have a tablet, I'm going to use it. I'm going to just copy this right here. Okay, I'm going to copy it. Paste it, bang, move it right here. Okay, so it's that same thing. Okay, great, and that's the answer for number 2. So that's one of the main situations where we use logarithmic differentiation. If you just have too much multiplications and powers and division, the natural log just turns it into sums and differences, okay, and multiplication. Okay, now this last one, why are we using logarithmic differentiation? Because you see how we have a situation where it's kind of like, you know, a function raised to a power of another function. Okay, if you notice, there's no other situation like this. So once if I take the natural log of that, it's going to equal the function up here times natural log of the function right here of the base. Okay, and so when we take the derivative, we're going to have to use the product rule. Okay, and this actually isn't. It's not as hard, I don't think, as the one we just did. So here's natural log of y, and I'm going to take the natural log of cosine of x. So I'm going to get natural log of y is equal to cosine of x times the natural log of x. Okay. Now, if I take the derivative of both sides, here I am switching up the colors. Okay, d dx. Remember, I have not taken. There's no derivative in the red part there. So I'm taking d dx. Okay, and what is that going to look like? It's going to look like, here's y prime over y, and that's going to equal, oh, we got to use the product rule, right? So what's the derivative of cosine? Minus sine of x. Okay, times ln x. Okay, but then we're going to do plus the cosine of x, okay, times the derivative of natural log of x, which is just 1 over x. Okay, so we're almost done. what I'm going to do is I'm just going to say, okay, y prime is equal to, I'm going to clean this up because this minus in the front, you know, it looks nicer if you move it to the other side. So we're going to have y times, what is this, cosine x over x, and know that as x's don't cancel, minus sine of x times natural log of x. Okay, and that gives us the final answer, which is that y prime is equal to x to the cosine of x times all this stuff. Cosine x over x minus sine x times times natural log of x. Okay, and that's quiz 6.